My name is Tyler Jewell, and this session is an introduction to Eclipse Che. It's a next generation Eclipse platform, and it's a platform that's designed to be part of a DevOps workflow and to help you build consistent developer environments. I'm founder and CEO of a company called CodeEnvy. We make cloud workspaces for development teams, both as a hosted offering and as an on-prem offering. But I'm also project lead for Eclipse Che, which is an open source project, and we're going to talk a little bit about that today. The project itself came online in January of this year, so it's been just over 9 months since it went beta the first time. And in that time, we've gotten about 3,200 GitHub stars, and there are about 100 contributors on the project now from companies including Red Hat, Microsoft, IBM, Samsung, SAP, Bitnami is involved with the project, MuleSoft as well. So a lot of good companies are involved, and of course my company CodeEnvy, we're the ones who created it here. So that's what we're going to talk about today. You know, we had a basic vision, which was to allow anybody, anywhere, at any time to contribute to a software project without having to install software first. And this idea came to me about 6 years ago, 2010 or so. I was working at a company called Quest Software, and I had risen to a certain level of management there, and I had gotten very sick. I was quite ill, and I was so ill that I was kind of offline for 9 months. And when I was offline, this particular disease, it was affecting my cognitive ability, and so I was having a hard time forming competent thoughts, completing full sentences and whatnot. I eventually recovered from that illness, you know, thank God. And when I did recover from that, I felt a little drained in that I had lost a lot of my technology skills. I was in management. I was spending a lot of time thinking about markets, but not necessarily being hands-on. And so as an old school programmer, I wanted to sit down again and reacquire my programming skills. And I sat down with Java and Maven and the Pet Clinic, the Eclipse IDE, Tomcat, and a few other technologies, and I'm like, hey, I'm just going to get this code working again. I'd like to hack on some code and see what it's like. And 3 days later, nothing was working for me. I couldn't get the IDE installed. I certainly didn't get the code compile. I didn't know what to fix where, and technology had just moved on beyond me. It had been 10 years since I had written any lines of code. And this is coming from a guy who had written 3 books on Java, you know, about 15 years ago. So there was a point in time where I had felt empowered, I had felt strong, I had felt very competent, I felt like I knew what I could do at a keyboard with programming languages and technology, and here I was, and I couldn't even get the basics to compile. And it was at that point in time where I got, you know, frustrated, I got embarrassed, and then I got angry. And it was that basic idea of like, I don't understand why this setup of a development environment is so difficult. Why can't I just have a link, click on that link, and then everything else magically shows up for me? And that was the basic idea for Eclipse Che and also my company CodeEnvy. And it was about the same time that story happened, that Vagrant came along and tried to provide development environments for virtual machines. How many in here use Vagrant? Okay, about a third, all right? So Vagrant is a popular technology that allows you to provision virtual machines, and then within those virtual machines, you can run these things called provisioners, which are essentially scripts, and then you can synchronize certain folders on your computer into those virtual machines. And the idea is that developers on different machines can do Vagrant up, and they get reasonably the same types of VMs. And that solution has been fairly popular. There are, you know, potentially tens or hundreds of thousands of users of Vagrant, but it has some drawbacks with it as well. If you've ever used this, you still have to deal with synchronizing VMs. So now you've got lots of developers on lots of computers, and they're using virtual machines. And these are large. They tend to take a long time to download. They're difficult to synchronize, and they can be slow to boot. And then the second thing is that it doesn't do anything to help you configure your tool set. If you're a developer, all developers demand a couple things. We call it an IDE, but really what you demand is a great editor, programming language intelligence, and a debugger. And the VM is going to do nothing for you to set that up. You tend to have to set that up on your desktop and then wire it in, and you have to configure it differently for each of the code bases that you're working on. So, while Vagrant, inches us along on solving this problem, it didn't solve it entirely. So, again, we came back to click a link, and then that's all you should ever need to know. So, if you're a developer and you want to make a contribution to a software project, there are 3 things that you need. Well, you need the IDE, which are the tools that you need to do your work. But you need your project files, which is typically the source code. And we get that from version control. We can do a git clone. There's our source code that's there. But you also need a runtime. Most people think, hey, I just get an IDE, I get my code, and I'm good to go. But you need a runtime as well. And the runtime is any environment that is used to analyze, compile, build, run, debug the code. Because you need a program to do that, and that program needs to operate against the code. Now, typically, when a developer sets up his workspace on his computer, the runtime that he gets is provided for him. The default runtime is localhost itself. It's the local host on the computer. And so whether you're installing the IDE or installing other stuff, you end up installing stuff onto localhost, right? And so it all goes there, and it becomes a very easy setup process for the developer, right? But it then starts to answer interesting questions around, hey, how do I start to move my work from one location to another, or if I wanted to recreate the exact same development environment, how do I do it? Once the developer gets all these things basically set up on their computer, they then create a workspace. And a workspace is a construct that exists inside of IntelliJ, it exists inside of Eclipse, it exists inside of Visual Studio. This is not a construct that exists inside of Vim or Emacs or Sublime. It's an IDE concept. But a workspace is a way of abstracting away a set of project files and then integrating the IDE with the runtime, right? And so you tend to think of your unit of work as your workspace. And so, okay, that's all well and good. You can go through that setup process. But if you ask yourself, how do you share that workspace? What do you do? And it's very challenging. Now, there are different technologies for trying this. So if you're a JetBrains user, they provide a configuration server, which is centrally managed, and it tries to synchronize various workspace configurations from computer to computer. If you are an Eclipse user, they have a product called Oomph, which will synchronize not only your configurations, but it will help you actually install the right version of the IDE as well. So it'll download the right version, install it locally, and then synchronize it. And there's another project out there called Flux, which will try to do point-to-point synchronization of your configuration from computer 1 to computer 2, right? But all these things require a lot of setup. But even if you used all those things, none of them synchronize the runtime. So everything that you installed onto localhost on that computer is not going to be installed somewhere else. So the JDK version, right, the binary, the database that you might be using, whatever that stuff is. So the problem is that localhost has its limits. It has its constraints. You can't share it. You can't control it. You can't scale it, right? So everything that we put onto our computers here basically limits us from making things reproducible. Eclipse Che is an open source project that provides a developer workspace server. It's a workspace server, and it's designed to make workspaces completely reproducible. And it does that by allowing for a workspace not only to include its basic projects, but it also includes all of its dependencies. All of its dependencies are included within the workspace. So what does that mean? So first, inside of Eclipse Che, workspaces bring their own runtimes. So when you create a workspace, your workspace will have one or more runtimes inside of it. Now, we use Docker to create those runtimes, but we hide the Docker implementation from the user. So the user comes along and they'll choose a workspace type, and then based upon that type and the components that the user requests, we will generate the runtimes for you. Then, after we've generated the runtimes and they're active, we then take your projects, your source code, and either clone it or mount it into the workspace. So the workspaces go from outside, or the project code goes from outside to the inside. And then each workspace serves up its own browser-based IDE from within the workspace. So your browser then connects to the workspace and says, hey, give me an IDE, and the workspace says, here it is, download it, and it's a bunch of JavaScript that downloads into your browser. And then we also inject what's called an SSH agent into the workspace so that you can SSH into those runtimes and mount your desktop IDE if you want. So you can pull up IntelliJ and make use of that. And then all of these workspaces are hosted in Che's server. So Che is a server for hosting these workspaces. Now, by encapsulating them in this way, we have a very concrete abstraction around what is defining a workspace. And this allows us to create clones of them, truly identical clones. We can snapshot them, and we can also move them from server to server to server, or from server to desktop and back. And they will always have exactly the same state as when you had last run them. We use Eclipse technologies inside of it to create a different kind of experience. It's a blend between a heavy IDE experience and a lightweight editor. And it's entirely in your browser, and we're going to show you what that looks like. And, but then, once you've got these workspaces in a server, they are collaborative. So a workspace in the server can be shared by 2 or more users. So 2 users can go into the workspace, they can be working on it at the same time, and there are capabilities around how you share that, and even multi-cursor editing that are in there. And we talked about them being portable, moving from computer to computer, but they also include their own APIs. So each workspace embeds its own API set running in, we call it a development agent inside, and you can connect to that and program, control the workspace itself, and then the same thing with the Che server. And this allows for a tremendous amount of automation. So much so where we have something we call a Chedir, which is a Vagrant competitor, and it essentially allows you to git clone a source repo. You can then do Che up, and we will convert the source repository into a hosted workspace in a server, even if you have nothing installed. And then it's available over URL, and anybody can gain access to it. So what is this like? All right, so we're going to do one last slide, and then we'll get into a demo. This is the architecture of Che. I think of it as a tripod. There is a Che server. It is responsible for coordinating all the workspaces that are going to get generated. Each workspace is its own independent set of runtimes, right? And they can run on the same server, or they can run actually on different hosts as well. After the workspace has been generated, your browser client or your desktop IDE client maintains a relationship both with the Che server and each workspace. So the browser makes a direct connection to the workspace into the agent, and inside that workspace will be a web terminal. There will be all the APIs. There's the SSH agent that we put in there, and there's a bunch of other things that go in there as well. The system is also designed somewhat similarly to Visual Studio or Eclipse, where there's a plugin architecture. So you can write plugins that are for a workspace, for a Che server, or for the browser itself, and completely customize how the system works. And so we've actually had some of our platform providers take it. You can strip it down into nothing and build it back up into a completely different sort of tool chain. So I've got a Che server running here. It's not hard to do. Is that readable on the back? That's probably not readable, is it? we can fix that. I've got this Che server running. I can do a Che info. The only prerequisite for having Che is you just need Docker installed. So the only prerequisite is Docker. That's it. And so you get Docker installed, and then everything we provide is provided as containers. So you run the Che server as a Docker container. The CLI is a Docker container. Everything's a Docker container. We've got like 20 or 30 containers, and we use containers as kind of micro utilities to do things. So when I did this Che info, this is running a series of containers that are going and getting information about my Che server, and it's basically telling me that Che is running, and it's all alive, and it even gives me the IP address here, and there's an IP address of the Che server, and sure enough, here it is. There, it's the same thing. I don't know if you can read up in that browser bar, but there it is. And this could be on my desktop. I'm running it on my laptop now. It could be on a server, right? We have people who use it in many different ways. So what I want to do is I want to create a workspace. And if you remember that process, the workspace has got runtimes inside of it. It then needs to mount some project code, and then we're going to activate everything. So I'm going to start with a real simple one. We have these things called stacks. Stacks are basically a way for us to describe the runtime, but stacks are just Docker files or Docker Compose files. And you can provide those if you want. So Docker files is a text-based syntax for describing what the runtime is going to have. And a compose file is a text-based syntax for describing how multiple containers are going to run. So I can do this first one in Java, but if I did this Java MySQL, that's actually a multi-runtime workspace. It'll actually launch separate containers for the database and the app server. I could choose from a library. We've partnered with Bitnami, and we've just gotten all kinds of stacks here. And of course, you can write your own. It's no big deal on that. So I'm going to choose the Java one, and then it says, okay, let's give your workspace a name. We'll call this Jenkins World, and we need some RAM. This one's going to take 2 gigs of RAM because we're going to create a workspace on it independent. And then it needs a application, so let's do that Spring application and create that project. So there it goes, and what it's doing now is it's going through an activation process. The first thing it's doing is it says, okay, this stack requires, it's going to be a container, and if it was a Docker file, it will build the Docker file. If it was a Docker image, it will download it from Docker Hub or some private registry. After it gets that, it creates the container. And then after the container has started, now we go into that runtime and we start a whole series of agents. So the SSH agent are agents which provide the APIs. And we're basically putting miniature Che servers, microservices, inside the workspace. And then after that's done, it's going to get the project code. And in this particular case, the source code came from GitHub. It did a git clone. And now it's loaded the IDE in my browser. It's set the project type here. And it's set the project type as Maven. And, and I will just get some files opened up here. You can see that it's recognized the project package. So it understands Java syntax. But I can come in here. And we've got a web terminal into the machine that's here. I can run Midnight Commander, which is a fun thing to do. I can see who I am. And I can go into this directory. I can touch Jenkins in that. Oh, there it goes. You can saw that I opened that file. I can echo hi there, and I can do more Jenkins, and So it's all synchronized in that regard on that. So nice terminal. I can add some more terminals if I want. We can do things like let's split it into 2 columns, and then add a terminal on the left and the right. All the sorts of basic things that you might do that you don't generally see in your browser, by the way. I have SSH here, so if necessary, I can. It tells me the instructions on how I can SSH into this machine from any other location, which is great. But we wanted to do some development, and that's well and good. So let's go back to our source code. We had opened this project up. I'm going to organize things a little bit. And it was a Maven project, and it recognized that it was the Java project, and so it also installed a Java language server as an agent. And a language server is a project that we are doing, CodeEnvy and Red Hat and Microsoft and a bunch of the other community. We just announced it 3 months ago. The language server protocol is a way to standardize the IntelliSense and debugging interfaces for all the languages on the planet, so that an editor like Che can implement this protocol once, and then as long as the language server provider like C or TypeScript or PHP or whatnot implements the same protocol, we can grab it, we can throw it into the workspace, and then suddenly you've got IntelliSense here. So we've implemented this and made it a distributed protocol so that you can run the language server inside the workspace, which is on the server, even though the browser's remote. And I did a control space there, and it gave me IntelliSense. And to show you that it's real IntelliSense, I can come up to a different location, and I get different types of commands. I could do an import org.here. I do that, and it gives me the package names. And if I do that for a second, it should tell me here that, oh, yeah, that import is never used. I can hit Alt-Enter, and I'll remove that unused import. All right, so, okay, cool, right? IntelliSense in a browser without having to install anything on my computer or configuring it. Okay, so I've got my code. It imported for me. Does it build, right? So, so we have this concept in the system called commands. And at the end of the day, whenever you do something like build or debug or run or analyze, you're just running a process on your computer. And so commands are a flexible way to basically define these processes and then make them reusable. And so I've got one here, build and run, and I go and launch that. And I got to close this panel so you can see close this pane. Here we go. And so there's the command. And in the green, this is actually what it got translated to, which is it's a Maven clean install. It's then going to create a WAR file, and then it's going to copy that WAR file and then launch Tomcat. And as part of that, it's given me a preview URL, which is the URL to the Tomcat server that's going to be started inside the workspace. So we've started the Che server, which started its own workspace runtimes. And inside those runtimes, we're now running a Tomcat server where our code is going to be deployed. And even though that's way deep inside of it, it gives me a preview URL so that the browser can go from the external internet and tunnel through all those different layers and get to exactly the project that I run. And it needed to download a bunch of Maven dependencies. It did that, and there it goes. And I click on that, and boom, we've got it working here. So what did I do? I installed Docker. That was the only thing that I had installed on this computer. I did Che start, which launched a Docker container, downloaded it from Docker Hub to boot up the server. And then inside that server, I chose a stack, I chose a project, and it brought along everything that it needed so that I could compile and run. And debugging is in here as well, including with the IntelliSense. Now, just prove that this was, my name is Tyler. Hit OK, and it says hello, Tyler, and that's great. And that's the code that we just ran there. There's a lot more. I mean, we could make a change to our code, and we could have the full range of Git capabilities here. And of course, we can do things like snapshot this. We could stop this workspace here. And once I do that, it starts snapshotting it. And what it's doing is it's saving the state of that workspace both as a configuration file that can be versioned, along with capturing the runtimes, because you've got these runtimes. And it snapshots those runtimes and puts those runtimes as images on disk. And so when you restart the workspace, it will grab the image, create a new runtime from that, then mount all the configuration of the projects into it, and you're good to go here. And so you can see that the IDE has been shutting itself down. It says the workspace is shut off, and it's not a very attractive view, but this is the way our IDE looks when the workspace is not started. So let me pause there. That was a lot to grab. Question? Yes, yes, sir. Yes, question. You can restart it as many times as you want. Yes. Yeah, his question is, can you restart it more than once? And yes, you can keep stops, restart.
I've got a bug, start it, show it to a friend, restart it, show it to a friend, over and over again.
That's right. Yes. And so the workspaces you can leave as always on if you want. Just leave it running, and then it acts as kind of a miniature staging server for you on that as well. The entire system itself is, let's see, let's get the right here. That was the dashboard. But you know, everything that the IDE is doing, the IDE is really a dumb client. And so if you just take your same URL, and all I did was change the IP address to have a /swagger at the end, and you can see the entire API set. And so you can start browsing the APIs, and you can see how we program the system. So the IDE is just a slave client to this IDE stack that we have. And you can navigate through this and see the methods that are there. All right. Other questions so far? Yes, sir. Ma'am. What's the average size of a Chase server? Well, if you're, the sizing of it really comes down to two variables. It's your RAM consumption and your disk needs. So on the RAM consumption, the workspace at a minimum is about 1/4 gigs. Like if you do the smallest agents that we have, you know, with the web terminal and the SSH and the API, it's about 1/4 gig. Now, and that assumes that you don't put any IntelliSense in there. The moment you put IntelliSense in there, your memory requirements are going to balloon like 1/2 gig to up to 2 gigs. You know, like if you get the JDT from Java, that thing is a beast. You know, that's like 1.5 gigs of RAM. So your RAM constraints are going to be dictated by the agents you put into it, plus then whatever your projects need to do. So after the agents are consuming the RAM, when I launched in there that Tomcat server, that was a real thin one. I only needed another 1/4 gig for that. So we need 1/4 gig for our stuff, whatever the IntelliSense is going to eat up, plus whatever your projects need on that. So that's the RAM side of it. And then in terms of the Chase server itself, it's nothing. Like it's just another Tomcat server. It's like 1/4 gig. So you can run a Chase server that hosts thousands of workspaces, and the server it will never even meet a blip. The other detail that you need to think about is the snapshotting. So if you're going to snapshot a bunch of workspaces and save them on disk, it really comes down to how thick your stack is. So like that stack that I chose there, which was, it had inside of it Tomcat and there was Bash and curl and OpenSSL. There was a bunch of stuff in there. That was Ubuntu, and that's about 600 megabytes. So every snapshot of that image will be 600 megabytes. We built with Samsung the Arctic IDE on top of this, and it does IoT development with it. Their stack that they built with all their tools inside of it was like 1.3 gigabytes. So, but that was like a kitchen sink sort of strategy. So it really comes down to, you know, do you want to cap how many workspaces are there and cap how many stacks that people can create on it? Yeah, in the back. So his question was, what's the support for Windows, .NET, and Visual Studio? So as you can tell, this is a Windows machine that I'm on. So Che runs on Windows. We've tested it on Windows 7 all the way up through Windows 10 on that. It is much better with Docker for Windows on Windows 10 than it is with boot to Docker on that. I'll just grant you that. In terms of the Windows Visual Studio support, we have a .NET and capability within the product. We've worked with the OmniSharp team, and they have an OmniSharp IntelliSense a language server that we've deployed in so that you get C# IntelliSense. And then we've got also a .NET stack that we provide out of the box on that. Yes. Yes, you could. His question was, can I do .NET with MySQL? And the answer is yes, you can. And I think we even provide an example out of the box with it. If I came in here and I wanted to create a new workspace, Create it from a new stack, create it from a stack. Yeah, it's actually one of the first things here. Yeah. Okay, I'll do a couple more slides and then I'll open up for questions again. So I started off this whole discussion as around this problem that I had about why couldn't I get it to work. And what I did show you here did require me to install Docker, and it also required me to go through some menus and click some things to create there. But I want to talk a minute about my company, CodeEnvy. And my company, we make cloud workspaces for development teams. And so we take Che and essentially make Che into an enterprise capability. And what we do with that is a few things. One is we make it multi-user. So while Che allows for collaborative development, the Che server does not have an identity in it. So all the users are sharing the same identity. So we have multi-user capability. There's multi-tenancy so that you can have groups of teams within that. And then you have permission control so that you can apply restrictions and invite levels to each workspace or to groups of users. And then we also provide a DevOps platform so that you can run this stuff at scale. So you can run it up to, I think it's like 1,000 nodes. And we support some really impressive companies that have tens of thousands of users on a single platform at the same time. But beyond that, one of the things that we do is we have this capability that we call workspace automation. We call it we label it a factory. But a factory is a way to describe the configuration that you want into a workspace and then make it shareable over the web. So let me, as an example of this, I'm going to go to the Eclipse Che website. Oh, look at that sexy product. All right. And I'm just going to come down here. And on this page, I'm going to come here because we have a lot of great examples. We have these things that look like stacks. And but this stack, this is a web page. I'm just on some website. And when I click on that link, even though I haven't installed anything, this is a link that has a workspace automation command that sends it off to CodeEnvy. And now CodeEnvy running at codeenvy.com or some other private CodeEnvy basically says, oh, you want to create a workspace. And so now it's creating a workspace which was exactly like the one I just demoed, but without me having to tell it to do that. So it was encoded into the URL, into the factory. And so a DevOps professional can create these factory links with your workspace templates and then package them up as URLs and attach them to webhooks. So you can attach it to Jira, you can attach it to your version control for each branch or each pull request. In this case, we just put it up on a website, but you could put it inside of your Jenkins jobs. And so the person who clicks on it, the acceptor, me, doesn't need to have an account. It doesn't, it doesn't need to know where CodeEnvy is. They just click on the link, and the rest of the sequence is there. And then there's doing other things. It's actually saying, open this file, run this command. And so without me having to do anything, I get to solve that problem that I had 6 years ago after I was sick, which is, why can't I just click on a link and this stuff just works? And within CodeEnvy, the workspaces are identical. You can move them from Che to CodeEnvy, CodeEnvy to Che. We're happy for people to use Che for free. We provide great support for that. But when you're ready for doing team development where you share your stacks, work together collaboratively, and you need to scale it up, maybe consider our offering here, whether it's in the cloud or dealing with us as a vendor and buying our software. But there you go. That was the entire same thing, the exact same project. And it's running here on one of our servers out into the cloud. And was that thing done booting? Yep. Voila. And that's the project that I couldn't get working after 3 days there. So if you are a part of an open source project, and you put this factory link, we make it easy for you to embed it inside of your repo. You can just add a couple of configuration files, and then we generate the URL for you. If you add that, we'll give you and all of your users who click on that 4 GB workspaces for free. So you just have to add that, and then you contact us, and we have a way to configure that so that it's free workspaces for your contributors, your committers, and whoever else wants to work on that. So this is about reproducible environments, productivity for the development team, automation for DevOps. You can take this product and strip it down and write your own plugins. You can change the UI. You can change the server side. The whole thing is customizable. We have a great group of engineers who are working on this every day. Some interesting stats. Last week we had 11,000 downloads of Che, so it's a big number and growing higher, and we had over 100,000 hours of usage on it as well. So it's a popular project. There's a lot of people who are going on with that, and we'd like for you to do it too. So I'm going to hang out here for the rest of the time. I'll take any questions that you've got, but if not, thank you for coming too. Yep. I couldn't hear you. Can you speak up a little bit? You have a workspace in IntelliJ. Can I move it somehow? So you can take the code that's inside of it, which is probably Maven or Gradle, right? And you can just import that project into Che, and it will be fine. There. It won't move the runtime. You still have to choose your stack, right? So you have to come in and either choose our Java stack, or you can add your own on that. So you can pick the right JDK that you want and the various flavors on that. Yep. Yes? That's right.
So I'm interviewing somebody, and he or she has a browser. We could both connect to the same session, for lack of a better word.
Yes.
Have you considered packaging this?
So like, if you consider doing pair programming and then packaging it up for like interviews and whatnot. So we package it up for all these various use cases. Yeah, I mean, and so you can run your own Che server and then share it on your own, or within CodeNV, we give you permissions and invites to do it there as well. Okay, thank you, everyone. Everybody have a great show. I'll hang out here as well.